Hello there, welcome to SEM 2, Lab 6. Wow, we've done 6 of this together. I hope you're getting better at your labs, alright? So in this experiment, you will investigate the motion of two masses connected by a string passing over a pulley. Okay, so we are going to, whoops, my OneNote just went all over the place there. Okay, so I think it's clear. You're going to look at the motion of two masses, all right, and then how it depends on the differences between the two masses. So the apparatus is drawn in a very nice 3D diagram like this, all right. So there is mass A, and then there is mass B. Okay, so if you look at this setup here, okay, I have my, I'm going to borrow the ruler a bit. Okay, so this is my mass A, the one on the left, and then the one on the right is my mass B. They look a bit different. I will explain why shortly. And in case you don't know, the pulley is way up here. This is my pulley. Later, I will bring in this camera, or rather this camera, very trippy, right? And allow you to look at it in close-up lah. All right, but let me explain the setup first for you. So in this, and I don't have the tray down here because in case you can't see, the color of the slotted mass and the color of my boxes are about the same color lah. So you may not be able to observe the slotted mass properly if I put the tray there. All right, it'll be blocking you. Okay, we'll continue. I know they say floor here, but you assume the table is the floor lah. All right, so we'll continue. Using the mass and the hangers provided, make both MA and MB equal to 100 gram. Okay, so what I did here was my MA is the slotted mass of 100 gram, single slotted mass of 100 gram, and my MB is 50 gram plus 5 times 10 grams. So this 10 gram is something that I can change around. And the reason why I want that to happen, so you can see this one here, it looks like a long stack, okay? So the reason why that is because I want to be able to transfer masses from B to A. Huh? So I want to take some of the 10 gram here, the 10 gram here, this 10 gram, I want to be able to transfer this from B to A. Bloop. So then one side will be 110 and the other side will be 40. No, the other side will be 90. Cannot match today. All right, so adjust the position of the apparatus so that the masses overhang the bench. So again, my masses are not overhanging the bench, they're overhanging my boxes here. Ding, 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 ding. All right. And we're going to continue. Let's see what we are supposed to do. Adjust the height of the apparatus so that the distance h between the bottom of mass A and the floor, or the table in this case, is approximately 1 meter. So what I want is h to be about 1 meter. Okay, so later I will place the ruler for you to measure h. Just a reminder, h is mass A and mass A is the one on the left lah. Okay, so you are asked to measure and record h. So we'll do that now. I will pause screen and change the scene a bit so you can look at the apparatus up close. Okay, I'm back. So you can see up here, this is the pulley. All right, this one up here, this is the pulley. This pulley will slide and roll as I push and pull the string. Okay, I'm not sure if you can see lah. It will slide and roll. Okay, so it's like a wheel that it can rotate, right? And then underneath this pulley, okay, underneath this pulley is my slotted mass. Okay, so I have two slotted mass here. The one on the left is MA. All right, this one is MA. This one is MB. They are now currently both 100 grams, so I can push and pull them however I want now. Okay, because the net force is 0, right? So what we're going to do is we're going to take some of these 10 grams here and put it here. That's the idea lah. But now you want to measure the height difference between the bottom of this mass A, bottom of this slotted mass, all the way to the ground. Let's see, where is the ground? Or in this case, where is the table? The table would be down here, lor. Okay, so we want to measure down here. So how to do that leh? Well, I am now going to set up the ruler for you. Okay, and hopefully adjust the lighting a bit so you can see clearly. And then we will take the reading of H. It just needs to be approximately 1 meter, not exactly 1 meter. All right, so I will show you the reading. Once again, a reminder, the position of my ruler will be touching the table like this. The bottom part here, the bottom part down here will be touching the table. Okay, and I will adjust the height of mass A such that if you look at this, the drawing of the experiment, this is such that I can get this height from the bottom of mass A all the way down to the ground. All right, so I'll do that now. Let me pause the recording. Okay, welcome back. So bottom here, this part, ruler touching the table. All right, so I'm going to slowly go up on the ruler. So here are some, I guess, reading. All right, so in this experiment, you will not be given a second retort stand to clamp. I'm just using this because I only have one hand, okay? And I need this to move my camera. All right, so here is our slotted mass, okay? So obviously you can tell that this slotted mass is not at 100 cm or 1 meter lah, because I am limited, I guess, by the length of the string. Okay, just to check out, the slotted mass is already hanging at the maximum height. Okay, so if you want to see this wheel rotating, observe the actual screw. See, it can rotate. So as I pull down, so I pull this down, it will rotate. Okay, anyway, I'm going to put it back up to the highest position. Okay, try to not shake the camera too much. So now what you can do is you can pause the video, right? Pause the video and take the reading for H. If you want a fiducial marker or a marker for this because you don't know the depth of field, parallax error here, parallax error here. Okay, so I'm going to try to put the camera as perpendicular as possible. All right. But this is the best that we have. So pause the reading, pause the video now and take the reading for H. Okay, just a reminder that the ruler is touching the table. So pause the video now and take the reading for H. And once you are done, I'm going to now pause the video and go to the next part of the experiment. All right. Okay, so I believe you have measured and recorded H. We're going to now move on to part D. Part D, right, we're going to take 10 grams from mass B and put on mass A, right? So what we'll do, let me adjust my camera a bit so you can see. Whoops, adjust the wrong screen. Give me a sec. Okay, so what we will be doing is we'll take the mass from B, which is this one here, okay? And we'll transfer 10 grams to there, okay? So what do we need to do? Once we transfer the 10 gram, you will calculate the mass difference. So make sure you know what to write here. I have already announced very clearly the masses that we have. 600 gram, the base is 50, and you have 5 individual slots of 10 grams, okay? I'm going to take one of these 10 gram and transfer over to A. You should know what to write lah. What is MA and what is MB, okay? And then after that, I will release the mass A from the height H, the value of H that you recorded above. So I'm not going to move anything else already, okay? You know that the H is the same because I put the top of this hook, because the top of this hook here is touching the pulley, okay? Anyway, to measure the time taken it takes to reach the table. So we'll do that now. And then after that, we will see what happens. So first thing, I will transfer the 10 gram from the left side, sorry, from the right side B to the left side A. And then I'll measure the time taken for A to drop. And as usual, like all the experiments, I will repeat the reading 3 times. Okay, so listen to my voice. I'll repeat the readings 3 times and you will use your stopwatch. So ready your stopwatch, and now we're going to measure the time taken. Okay, we're back. And I'm not sure if you could tell, but the 10 gram is already transferred. Whoops. I guess you could tell from the sound. All right, so the 10 gram is already transferred. This is a 10 gram. Okay. And the other side here is 90 gram. So as you can probably see, when I hang it, one side will have more mass than the other, creating a net force. When there's net force, then there will be an acceleration. And of course, the time taken can be measured. All right. So now I'm going to zoom out the camera so you can observe when this mass A, this is mass A, okay, mass A, when the mass A hits the ground, and measure the time taken. I will repeat the experiment 3 times. All right, 3 times repeat so that would give you a good reading. Yes, that is what we will do. All right, so this is the front view. Okay, so what we're going to do is I'm going to hang this now, and you will measure the time taken. I will tell you by mic and also by hand gesture whether this is the first, second, or third reading lah. Okay, are you ready? If you're ready, let's go. Okay, so guys and girls, this is what I'm doing now. I'll hang this here and hopefully I don't pull out my headset from the computer. Okay, so I'm going to adjust this such that our 100 gram, you can say, wow, shake left, shake right, so difficult. Can write at the back. Your limitations and uncertainty. Probably right. Okay, so here is the entire setup. I am holding this thing in place so that it doesn't fly down. So you get ready your stopwatch. Okay, when I release my hand, basically you are measuring the time taken for this one on top to fall to this ground. All right, so we're going to do 3 tries. This is first try. Okay, first try for this one to drop. Okay, I'm going to try to make this as vertical as possible from my perspective. All right, if you're ready, go. Whoops. So you can see there are a few problems there. Please make sure to write that at the back of the question. So I guess that one was an NG or a no-go. We are going to try again. We're going to try again. All right, so do not entangle. This is a question 2. So if let's say the conditions are still unfavorable, then we'll still have to take that reading on its own. Okay, so if you're ready, 1, 2, go. Was my hand in the way? I apologize. We'll try again. So you better, yeah, you must have the feeling. You must have the feeling of doing this in the lab, what? So the sudden crash, the sudden clang and clang is part of the experiment, guys. Since I already saw everything for you, I must try to recreate the lab experience, what? Okay, you don't topple down, okay? If not, my laptop will be GG. RIP. Alright, so I'm gonna adjust this to make sure it stays in place. Okay, so I guess that could be the first reading. Alright, and I'll make sure I leave my hand out of this. Okay, so second reading number 2. Let's go. Oh, that was perfect. Alright, let's go. Reading number 3. Ding 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 ding. So reading number 3. 3. Whoops, wait, wait, I need to make sure my hand is placed properly. Okay. Do you want 4 readings? No lah, I think 3 is enough already. So you know what to do, okay? So this time, when you release, you know lah, okay? So you have to estimate the percentage uncertainty for your value of T. And now at this part F4, we are going to transfer another 10 gram from mass B to A and repeat the steps again. All right. So I'm not going to, oh, I guess I could. I will zoom in now for you. Okay. So I will now place the okay, so I'm gonna change the value of M. I think I'll stand up and do this for you. So this one here is the 10 gram. I'm gonna take the 10 gram, take it out from this one and put it here. So why cannot go in? Hello, please go in. Why you stubborn? Slotted mass, excuse me. Is it thermal expansion? Is it because, no wait, thermal expansion means it should be easy to get in. Give me a sec. We have a problem. Doesn't want to go in. Real experiment pane. I don't think this one is some limitation that you can write because it's the limitation of the instrument that is given to you. So don't complain so much about the instrument unless the instrument is not sensitive enough. Complain more about the method of the experiment. Okay, this is no dice. I will find another 10 gram. Are you willing to go in? Yes, you are. Better. Alright, so what we have now in this setup is mass A. Alright, I'm going to make myself a bit bigger so we can use the webcam. Ooh. Alright, so this is mass A. Can you see mass A? There we go. This is mass A. 100, 100, 101, 102. Cool. This is mass B. 50, 60, 70, 80. Okay, makes sense, right? Okay, hopefully the maths makes sense to you lah. If not, then you ask in the comments or ask me in person. All right, so now I'm going to change the scene so that we can put this on the pulley. So I'm going to hang this like some Chinese New Year ornament on the pulley, which is weird, but okay. So let's scene change now. Bloop. Okay, so I'm going to put this on the pulley. Okay, and I'll adjust mass A such that it is at the highest position once again. Alright, so your mass A is hanging up here. This is mass A. Mass B is here. Okay, mass B is 10 grams lighter because I put 10 gram up in mass A. Alright, so now we are ready to begin. Are you ready to begin? Are you ready to begin? You're ready to begin? Alright, so this is the second set of readings for MA and MB, where I have already transferred 20 grams from B to A. 20 grams from this to that one. So I will release it and hopefully they don't clash into each other. This is first try. Ladies and gentlemen, let's go. Okay, a little bit violent, but I'll take it. All right, second try. Bing, 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 bing. Whoops. Well, hello. Everything is fine. It didn't hit my laptop. Or else you won't be seeing this. Life is hard. Did the entire slotted mass drop? Okay, let me go and hunt for my slotted mass. I think I broke the string. BRB. Okay, exciting times. I'm back. I have readjusted and reset everything, making sure that all the dimensions are still the same. Okay, so we're going to now do second reading. Technically, you could take that one as one, but we shall not do it now, okay? Second reading for the second set of MA and MV. All right, and to make sure it doesn't happen again, I'll put my hand here to support you, my retort stand. You give people support all the time, so now I'm my turn to support you. All right, so I'm going to try my best to make sure it works. That thing has to stop oscillating. Give me a sec. Chill, chill, chill. Don't move. Okay, better now. And we are ready to go. Ready your stopwatch. Second reading. Ons. Okay, that was good enough. Now it's time for third reading. I will return this to its original place. Third and final reading for T. Okay, let me crown you again. Hang the necklace. Stop oscillating. This is not the experiment. Stay there. Okay. All right. I'm gonna do the third reading now. Reading number 3. 3. Okay, 3. Ready. Steady. Go. Aya, there was collision. So, probably gotta do again. You know what to write, right? At the back. As you observe the experiment. Many problems. Like I said, question 2 is purposely designed to make your life difficult. And if you're recording this like me, it makes my life extra difficult. Somehow I'm recording this the evening before Chinese New Year reunion dinner. Fuyo. Okay, ready, Mo? If you're ready, let's go. Okay, that's enough excitement for now. I think you have 3 readings. You just estimate your best one lah, okay? And what we need to do now is let's look at the lab report again. And I want you to think about all the possible limitations. You saw me struggling. So when you write about all of this inside your question 2, and this part here, there are so many things to write about. How can you improve this experiment so that the very obvious problems won't happen? Quite a few of those obvious problems are already recorded on camera, okay? And also the problem of you timing things that is not related to the fact that you're not in the same room as me, but related to the fact about maybe the time is a bit just too short. I don't know. Figure out how to write this, okay? The rest of the things are standard. Please try not to repeat the mistakes that you have already done for the first 5 labs. So I suggest that you actually take some time to review the labs that you have done, look at the mark scheme, even better look at the examiner report, and figure out how you can improve and don't repeat the mistakes around decimal points, repeated reading, estimating uncertainty, how to write all these justify number or significant figures, explain supported relationship. Because I have looked at a few of the scripts from students and they are still struggling with small things that will cost them 1 or 2 marks here and there. But you know, every mark counts, right? You're working so hard for your A-levels right now, watching a video online, looking at trying to focus on what is happening here. So I hope that your effort will be paid off. Yeah. Okay, so that's it for question 2, set 6. The year and variant will be in the description or will be told to you later if you're doing this with me in the college. This is a flywheel experiment where we change the masses by changing the masses of A and B, we change the acceleration and we measure the time taken for the slotted mass to fall. So this is a kinematics experiment, or something is moving. When something is moving, there are certain uncertainties and limitations that always applies. So think about what those uncertainties are, and we are only 2 more sets left in this semester, right? So please take this time to improve and prepare for your paper 3. I will see you in the next experiment set. Take care. Bye bye.